RDBMS versus data warehouse, understanding the differences and bridging the similarities. In today's data-driven world, effective data management is the bedrock of decision-making. Two prominent approaches often discussed are Relational Database Management Systems, RDBMS, and data warehouses. While they may seem similar, both handling data storage and management, they have distinct purposes, architectures, and features that make each uniquely suited for different applications. Here, we'll dive into the key differences and similarities between RDBMS and data warehouse technologies to help you better understand when and where to use each. RDBMS. Typically, RDBMS like MySQL, PostgreSQL, and Oracle focus on managing transactional data. They are optimized for day-to-day operations, supporting high-speed transactions, updates, and deletes. Commonly, they power applications where real-time data is essential, such as order processing, inventory management, and CRM systems. Data warehouse. Data warehouses like Amazon Redshift, Snowflake, and Google BigQuery, on the other hand, are designed for analytical processing. They store historical data aggregated from various sources, transforming it into a format optimized for querying and analysis. This setup enables businesses to conduct complex data analyses, identify trends, and make strategic decisions. Key difference: RDBMS are transactional, used for day-to-day data operations, while data warehouses are analytical, enabling strategic data analysis over time. RDBMS. Structured data is the cornerstone of RDBMS. Tables in an RDBMS are organized in rows and columns, adhering to predefined schemas and relationships. Normalization, reducing redundancy, is a common practice, ensuring data integrity and efficiency in storage. Data warehouse. Data warehouses typically follow a star or snowflake schema for organizing data, which is more denormalized than RDBMS. This denormalization improves query performance for analytical workloads, since it reduces the number of joins needed for complex queries. Key difference: RDBMS are highly normalized to ensure data integrity, while data warehouses favor denormalized structures to enhance query performance for analytical tasks. RDBMS. RDBMS excels in online transaction processing, OLTP, which requires quick atomic transactions with frequent updates. OLTP is essential in scenarios where speed is crucial, like ATM systems or online order placements. Data warehouse. Data warehouses are built for online analytical processing, OLAP. OLAP involves complex queries on massive datasets, retrieving data across multiple dimensions for analysis and reporting. Key difference: RDBMS supports OLTP for fast, frequent transactions, whereas data warehouses excel in OLAP, optimized for large-scale data analysis. RDBMS. Since RDBMS are transactional, they provide real-time data, crucial for applications that require immediate updates and consistency. Data warehouse. Data warehouses usually work with batch processing, where data is loaded in bulk periodically rather than in real time. However, modern data warehouses like Snowflake and Redshift now support near real-time data streaming for analysis. Key difference: RDBMS provides real-time data for immediate operations, while data warehouses typically use batch processing for large-scale analytics. RDBMS. Traditional RDBMS were designed for single-server architectures, which can limit scalability, although distributed databases like MySQL cluster now support horizontal scaling. Data warehouse. Data warehouses are built with scalability in mind, often using distributed storage and compute clusters that scale horizontally to handle massive datasets. Cloud-based data warehouses like BigQuery or Redshift provide virtually unlimited storage and computational scaling. Key difference: data warehouses generally offer better scalability and can handle larger datasets due to their distributed architecture compared to traditional RDBMS. RDBMS. Data in RDBMS is often transactional and comes from a single source or application. While some integrations exist, RDBMS are not typically designed to aggregate data from multiple sources. Data warehouse. Data warehouses are central repositories designed to collect, transform, and store data from various sources through ETL, extract, transform, load, or ELT, extract, load, transform processes. They enable businesses to analyze data from different departments, regions, and even third-party sources in a unified environment. Key difference: RDBMS focuses on single-source transactional data, while data warehouses consolidate data from multiple sources for in-depth analysis. RDBMS. Ensuring data integrity is essential for transactional systems, which rely on ACID, atomicity, consistency, isolation, durability, compliance to maintain consistency across updates, deletes, and inserts. Data warehouse. Data warehouses use a more relaxed approach, as consistency is not as critical in the analytical context. Instead, they focus on providing historical accuracy for analytical queries. Key difference: RDBMS focuses on strict data integrity with ACID compliance, whereas data warehouses prioritize historical accuracy over real-time consistency. Where they overlap: similarities between RDBMS and data warehouses. Despite their differences, RDBMS and data warehouses share some key similarities. Structured data. Both RDBMS and data warehouses are based on structured data, using SQL, structured query language, for data querying and manipulation. Data storage models. Both technologies organize data in tables, rows, and columns, adhering to relational models that simplify data access and retrieval. Data security. Both RDBMS and data warehouses implement stringent security measures, including role-based access control, encryption, and authentication protocols. Reliability and backup. Both provide mechanisms for backup, recovery, and reliability to protect data, with redundancy built into systems for fault tolerance. Use RDBMS. When your application demands high-speed, real-time data processing, transactional integrity, and single-source data, RDBMS is the best choice. For example, e-commerce applications, banking systems, and CRMs rely on RDBMS for efficiency and consistency. Choose data warehouse. When your focus is on long-term data storage, comprehensive data analysis, and deriving insights from aggregated historical data, a data warehouse is more suited. Companies needing advanced reporting, trend analysis, or multi-source data integration benefit greatly from data warehousing solutions. Understanding the unique strengths of RDBMS and data warehouse technologies allows businesses to utilize each effectively, whether for daily operations or for strategic, data-driven decision-making. With advances in cloud data warehousing, businesses can now even bridge these two technologies, capturing the benefits of real-time processing and historical analysis in a unified data architecture. Thanks for watching. Visit the website https://sbdevblog.com.